day 6. So just double click and open RStudio. Okay, so far we already put session or heading so that we can easily browse different parts of our R script. Okay, so why don't we just run the whole script? So to run the whole script, we can press Ctrl Shift Enter. Okay, so always leave enough space so that the graph will appear. Otherwise, you will have an error saying that the figure margin is too large. Okay, so this is one of the trick for you in RStudio. Okay, so far we have black and white. Okay, our histogram is black and white. So to be more lively, we just want to put color. So why don't we put color red for male and blue for female? Okay. Okay. So we need to change a little bit of our code. Okay. So this is the code that combine different histogram into one graph. Okay, so we need to change the histogram command, add more arguments. Okay, so as you can see that this goes beyond to this side, beyond this side. So why don't we just put to the next line? Okay, press enter, and then we will put a comma here. Okay, put a comma, and then we will use an argument called color, C-O-L. Okay, color. So you just click, you just press tab key. Okay, so we will put red color to male. Okay, so we will put this. Okay, so let's see whether it works or not. So let's try and run in this line. Okay, so we got red one. Okay, so do the same. Okay, so we will put to the next line. Then we will put color blue. Okay, so it's easy. Just put color argument COL, and then you put the name of the color you want. Okay, so if you want green, if you want blue, if you want gray, anything you want. Okay. Okay, so we'll run this. Okay, next do the same. Okay, do everything the same. So this is May, so our color will be red. Okay, and run it. Next, okay, it is female, so we will put blue, color blue. So run this. Okay, so the same. The idea is the same. So this is May, so we will put red. Next, we will put female as blue. Okay, so run this one and then this one. So basically, we put red color to male data set and blue color to female data set. So anyway, you can put any color you want, but again, so if you're going to publish some article, I mean most journal nowadays accept color figures, color graph, but sometimes if you have to pay, then adding color figures will cost you more. So they charge additional money for color figures. So anyway, you can choose color or black and white. Okay. So usually black and white is sufficient, but if you want to put color, it's more lively and it's more attractive. Okay, so let's go and uh, add a new session. Okay, and we will move to Barplot. Okay, so we will move to Barplot. Okay, so Barplot is for categorical variable. Okay. Okay, so let's try with sex. We got okay. During previous data exploration session, we know that we have 12.2 value in sex. Okay, so we are going to replace 12.2 with any in age. Okay, so let's try this. We got patient, and we will use piping. Okay, so we put the data set patient into the piping and then go to the next line. And we will replace okay, age and a if age is sorry not age, sex. Okay, we will replace sex with any if sex is equal to 12.2. And then one way to check is uh, before you make a histogram, just tabulate it. Let's see. Okay, so these are not fixed command line. We will just delete it. Okay. Okay, so we got male, female, and then we got any. Okay, so you can just remove this tabulation function, and then we will add with. Okay, and we will put dot instead of the name patient, that is the patient, because dot represent that data set, modifying data set in our piping function. Okay, so right now we have our data set and we use width, so we can just call the variable. Okay, so we will make a bar plot. So the function is bar plot. Okay, so bar plot here is a little bit tricky. Okay, it's a little bit tricky. Before we go on, why don't we just try to run this? Okay, with patient, and then in order to put in order to make a bar plot, you need to create count for each category. Okay, you need to give a count value to each category. So we do this by using table command. Okay, so table and then sex. So I just want to let you know what kind of data are we putting into Barplot. So we just when we just run this, you can see that okay, wait, okay, you can see that we got, okay, we haven't removed this one in this line. Okay, so we got three category, male, female, and the count. So these are the frequency value. Okay, so in order to make a bar plot, you just have to do it. Okay, so I will delete this. So you mention bar plot. Okay, you got a function, and then you make a frequency of sex. Okay, anyway, you just remember this. Okay, previously we make a histogram and we put a variable. Okay, in Barplot, this is no longer the case. You have to create a table, okay, with a count value. So we create count value using the function table. and then we make a bar plot based on that value. Okay, so we're trying to run this. Okay, so as I mentioned, this margin is narrow, so as you can see that what happened. What do you think happened in our in this graph? Why
Created a,
does, sorry, go on.
we created a six tables. We compare with
Yes,
the answer.
that's the reason. That's the reason, right? So we set our graphical parameter to six. Okay, 3 columns and 2 rows. Sorry, 3 rows and 2 columns. Okay, so what do we have to do? So we have to turn off the graphical parameter. We gave it to R. So how do we do this? We have to do this device off. Okay, let me check. Let me check. Okay, so I will run this. Okay, yes. So whenever you set the graphical parameter, you need to turn it off. Okay, you can turn it off as soon as you run this command, or before you run another before you make another graph. Okay. Okay, so you turn off the graphical parameter. So basically you just, delete every graph. And then you run this again. Okay, so now it becomes bigger. Okay. Okay, the problem with this is, what is the problem with this? It's a little bit awkward, right? Because we only have male and female. We don't even have a title here. Okay, so we will change 2 things here. Okay, number one, we will put the title here. Okay, number two, we will put how high the frequency here. Okay, so we need to give additional argument to the barplot function. So we put our cursor here. Okay, after table function, so put a comma. You already know how to add a title, right? We discussed this in histogram. So you mentioned the argument name, which is main. This is the bar plot of sex. Okay. Anyway, let's check it first. Okay, so we have a bar plot of sex. Okay, with the argument main, basically main title. Okay, next, what are we going to do? We will put the value, okay, the frequency value. How many patients are female and how many patients are male. So we do this and we give another comma. We do this by mentioning another argument called frequency. Oh, wait, label, not frequency. Label is equal to wait. Wait. Let me check it first. So anyway, when you found such error, you need to check the documentation. Okay, So how do you check, how do you search documentation for each function? You put a question mark and then you write your function, okay, Barplot. Or you can check table, okay, question mark table. So this is cross tabulation and table creation. Okay, so this is different from mstat. Okay, this table command is different from mstat. From for mstat, the tabulate function, tab function, generates the cross tabulation with details. Okay, it has frequency and percentage, row percentage, column percentage, and other numbers. This cross tabulation, as we already seen above, it only generates the frequency. Okay, nothing more, only frequency. So even though it just give you the it says here that it provides cross tabulation and table creation. It does not. It only gives the count. Okay. Okay. Anyway, let's go back to Barplot. Okay. One thing you can do in our console, if you are lazy to type, is you can use up and down arrow key, okay, to browse your previous command. Okay, so down arrow key, up arrow key, and then click enter. Okay, wait. I think it should have the um, okay, okay, and right now we won't do this yet. Okay, I think lever is for histogram, not for Barplot. Okay, right now what we are going to do is, okay, we already changed the title. What we are going to change is we are going to scale, and not scale, we are going to set the y-AZ. Okay, right now it goes from 0 to 70, and you can see that this bar is a little bit higher than 70. So we will give more than 70. We will change the range from 0 to say 80, okay, or 90. Okay, so that is what we are going to do. So how do we change this? So put a comma and then we will go to the next line. So this is y-AZ, okay, and we will add an argument called y limit, okay, lim. So there is a limits for y-AZ. So we will choose this and we will give a range, okay, from 0 to 80. So you have two values, so you have to put this together with C. Okay, C puts the value together. So you say you mention 0 to 80. Okay, so that is what we are going to do, not the lever. Okay, so it looks a little bit better. Okay, but later on we will look at how to add the lever. I mean, in Excel we call data lever. Okay, here. But I think to add data level, you have to use another function called text and put it. But right now, don't worry about it. Okay. So these are just data exploration. So at least you can guess that it is between 60 and 80, so around 75. This one is around 45. Okay, so obviously our data set have more female than male. So this is how you create barplot. Okay, so any question at this point? Okay, so I think next is like we did in histogram. What we can do is we can put different color, okay, different color for male and female, and female and male. Okay, so we will go behind this round bracket, and then we will put an argument, the same argument, color. I think this will work. Okay, so you need to specify two color, okay, for each bar. Sorry, one color for each bar. Okay, so we will say the first one is blue, okay, consistently to be consistent. Second one is red, okay. Let's see if it works. Okay, it works, right? So anyway, this is how you do in how you make bar plot in R. Okay, so we already set the title of the bar plot and also the y-axis, and also we add color. So at this point, what we have the new function we just discussed is y limit. Okay, so the same principle. If you want to change the x-axis, then you can use x limit argument. Okay, but we don't have to change here. Okay, we don't have to change here because x-axis is not continuous anyway. Okay, anyway, let's say I think I have a questions from another group that what if we want to change this value? Okay, we can do the same way with replace. Okay, we will call we will change male to man and female to woman. Okay, so we will say this. Okay, sex to sex. We will change this man if sex is equal to male, and then we put the piping command, and also we replace sex to women if sex is equal to sorry, yes, female, and then we put piping command. Okay, so make sure that your you put piping symbol at the end of every line. So as you can see that our data management is really easy, right? So you run this. Okay, sorry. You run this. So you can see that the order change, okay? Because are arranged automatically arranged alphabetically. So in this case, M comes first, okay? W comes later. In male and female case, M comes later and F comes first. Okay, so in this case, we need to change the color to be consistent. Wait. Okay, so women we put blue and man we put red. So this is how you change the value. Okay, and the order. If you want to change the order. Okay, so next, what we do when we have two categorical variable, okay, even three categorical variable, we talk about this. We can visualize using Mosaicplot. Okay, this what we are going to create is called Mosaicplots. Okay, so we will use the function mosaic from base R. Okay, so these are all base R, and then we will cross tabulate. I mean, we will use two categorical variable with smoking HS and family HS. Okay, so first let us check patient. Okay, and we put it into the piping, and then first we need to tabulate it. Okay, because say we forgot what values are there in these variable. So we don't know what's in family HS, so we will tabulate it. So you can see that we have minus 99. Okay, and then we have smoking HS, and run this again. Okay, so we have minus 99 in this category. Okay, so we just remove this, and first we will replace the minus 99 value. Okay, replace from family HS with NA if family HS is equal to minus 99. I think the reason I'm repeating all this is for you to familiar with the concept. Okay, because I think people feel that R is a little bit difficult to learn because of this. So that's why I'm repeating these comments or functions several times for you to familiarize. And next, we are going to replace smoking HS with NA if smoking HS is equal to minus 99. Okay, so now why don't we just tabulate it again and see if it is, you know, if these values are gone or not. Okay, so these are because we just, narrow our graphical space. That's why there is this error. Okay, never mind this. So as you can see that we have an A value here. So I think before we go on, why don't we cross tabulate these two variables by specifying a bind argument. Okay. Okay, so this is our okay, let me run this again. I think we need a little bit because there are three categories of smoking, counterformer and never. Okay, so anyway, if you found any errors, then what you can do is you can remove the NA value. Okay, NA dot RN to true, because sometimes if there is an NA, it doesn't work. So you can just put NA.IN and trying to run this if you found any difficulties. Okay, so here either you put you remove NA or not. This what appear. Okay, so it is working fine. We don't have any invalid value anymore. So why don't we trying to create a mosaic block. Okay, so Mosaicplot, the function name is Mosaicplot. Okay, Mosaicplot, Mosaicplot. And to create a Mosaicplot, it's a little bit different. Okay, just trying to remember this. You put a tilde sign. Okay, tilde sign. So usually the tilde key is on your above the tab key. Okay, so look above the tab key, and you press with shift. Okay, shift with the tilt key. So you will get this tilt symbol, and then you put every time every variable you want behind. Okay, so family HS, and then you combine them with plus. Okay, anyway, you have to put the data set here. Okay, the data argument. So the data argument here, we will put the dot. Okay, dot, because the name of the data set from the piping function is dot. Okay, so let's run this. So you will see that it's going to appear like this. Should appear like this. Okay. Do you have any problem with this? Can you run this?
I'm having trouble. Sorry.
Yes. What trouble?
Somehow the code didn't run. It says
Okay.
error in data frame data.
Okay.
Object family as not found.
Okay. So can you share your screen? I'm going to stop this, and can you share your screen? Okay, so that everyone can learn.
Okay, just one moment.
Okay, it's fine.
Okay, share. So this is what I'm having right now. Maybe I made mistake somewhere here.
Okay, you didn't put the symbol, piping symbol. Okay, that's one.
Oh yeah.
Okay, so can you share your screen?
Okay, just one moment. Share screen or studio. So I'm having this here right now. Error in evolved pre-data set. Object family history not found.
Okay, let me just read it. Okay, because the reason is you already tabulate in line 138. Okay, so you just comment it out, line 138, line 138. You comment it out. Okay, or delete it. Line 138.
138.
138.
Okay, this one.
Yes. You delete it, or you can comment it out. Okay. So try run this again.
Just one moment.
You can leave it. Okay. You can leave the empty line. It's all right. Okay. Okay. So perhaps okay, some of you will notice. Can you press Control Z? Control Z and Control Z again. Okay, so can somebody tell me why, or maybe tell everyone why this, why if we put this tabulate function in line 138 and why this code doesn't work? What do you think?
Maybe because tab is not the graphical function.
No, graphical function is correct, and everything is correct. But what do you think it happens? Why do you think it happens? I think this is a little bit, you know, this is not advanced, but it's a little bit more than basic. Okay, I think it is good that we discuss this issue so that you will have more knowledge. Okay.
We already table that the family history and smoking history by the typing function. So the carryover function doesn't work. Is that?
Yeah. That is the question I'm asking. The carryover function doesn't work. Why it doesn't work?
Because we already tabulate it.
And we tabulate it. So I think you are partly right. Okay. I think the answer is right because we tabulate. But why? Why when we tabulate it and then when we carry over it, and it says that family H is not found.
We already merged that two variables in that table function, so the carryover function will not look over the separate variable, I think. Is it?
Yeah, almost there. Okay. So does anybody want to try? Other people want to try? So I think if you just consider, okay, we put the patient data set here. Okay, so what I say is data set. Okay, so when we in line 135, we put data set and replace in line 136, replace family HS, and then we got data set, and then we put to the line 137, we got another data set. But when we put into the line 138, what we do is we tabulate, which gives us the tabulation, not the data set. Okay? And then we carry that data set. Oh, sorry, we carry that table, tabulation, not the data set. So in line 138, we do not have data set, no longer have our data set. What we have is we have tabulation. Okay, and then we put it into line 139, which use our data set, which should use our data set, but we didn't see anything. Okay, okay, so I think you got your answer right. Okay,
yes, yes.
And let me change it back to my screen, and I will demonstrate it.
Thank you very much.
So I think I'm going to comment out this slide. And what I'm going to do is I'm going to show you when we tabulate it, okay, what happens. Okay, let's say we only we tabulate one variable. Okay, so when we run this, we have our tabulation. Okay, what we call this is output or display. Okay, whatever display here is for you, it is for your eyes only. Okay, so what we can do is we can see, we can put this tabulation to another to next line and see what is there. Okay, using Copot. Okay, Copot, and then we put our data set, because carryover data set is this one. So we no longer have data set, we have tabulation table. Okay, so okay, anyway, we cannot use it because it's not data set. Okay, anyway, let me try this. Okay, what we are going to do is we're going to put this, okay, test tabulation. Okay, we are going to assign this into this one, test tabulate, and see what kind of output we get. Okay, not this output, the output behind the scene. So we're going to we will run this. Say we have this one. Okay, so you see it changes, right? It's no longer saying what observation or what variable. It say it is a list. Okay, it say it is a list. So we can, when we check this test tab and then run this, okay, we want to see what is inside this thing. So we will run this. So you can see that inside that is not our data set. It is the tabulation. Okay, so that's why when you accidentally put this thing in the middle, then your output is wrong. Okay, this no longer can continue because there is no family HS variable and there is no smoking HS variable. Okay, anyway, we will cover this at the end of our course. Okay, because this is also rather important. Okay, this is also important because let me just demonstrate quickly. Let's tabulate everything of patient data set. Okay, so when you run this, you will get lots of lots of tabulation. Okay, you will have several tabulation. Say you want to convert it into the Excel sheet. So what you can do is you can assign this, okay, into result, the output into the result. Okay, so we will run this, and you can see that there is a list, 7 lists, okay, 7 tabulation. And then what you can do in AmStack is you can export, okay, these tabulation into Excel. Not Excel directly. We will write this into okay, CSV format. Okay, and I did this for demonstration, but we will discuss this at the end of our statistics course. Okay, because this is also important. When you analyze and write a manuscript, you need to create tables. So this is how you create table 1. Okay, but our data set is not that clear, but this is for demonstration only. So you run this. Okay, so this result, whatever the tabulation there are, we save it into result.csv. So I'm going to open this and I will show this. Okay, so I just opened the result.csv. Okay, so this is how the result look like. Okay, so you have your frequency and percentage, and usually we don't need cumulative percentage. Okay, so you can copy this, copy paste to your table, or you can use this to create a table. Okay, so you just delete this one, and then you have frequency and percentage. Okay, so you can quickly do this by saying okay, this is called a, and now what you can do is we remove, okay, there are a lot of okay, wait a minute, should be, okay, we remove this line. I mean, these are just, you know, if you can use Excel pretty well, then you can create this one. Okay, so this one is variable and this one is frequency and percentage. So anyway, you can export whatever result from tabulation or summary summary measure from AmStack and put it into Excel really quick. Okay, so this is how you do it. Anyway, this is not the focus of today's session. Okay, just if you still don't understand this, just forget it. Okay, I just want to explain how why the error happens and what is being pushed forward in this piping. Okay. Anyway, we got our Mosaicplot. So when you look at this one, it's pretty nice, right? Pretty clear. And as you can see that you should also read this documentation if you want to, I mean, use it very well. And you can see that there are a lot of argument here, okay, which we are not going to discuss in detail, okay, because it will take a lot of time. And as I said, there are a lot of functions. There are too many functions, and we cannot discuss all these functions in detail. Okay, so what I want to do in this course is I just want to introduce to these functions, and then you can read more in details on this documentations, or you can just Google it. Okay, say how to add color to histogram. Okay, this is how you do it, because you cannot remember everything. And still, even I cannot remember, even with histogram, I have to search on how to do it properly. And there is no shame in that, okay? Because we also have other we also have other tasks to do in our life, not this R, okay? Okay, so that is how you do it. I think here what you can do is we can add the title, okay? Because our title is not, there is no title yet. There is a title, but it is dot, so nothing meaningful. So we put a comma, and then we put main, okay? And then we say this is Mosaicplot, or whatever you call it, okay? You can name anything you want. And family HS, okay, you can say family history and smoking history. Okay, so when I say that you can put to the next line, probably you will notice that I always do this after a comma. Okay, what I'm trying to say is you cannot do this here. Okay, if you do this here, okay, let's try. If you do this here, what happens? It goes to the next line, right? So it's not appearing, it's not what we want. So it's not good to do that. Okay, so you were asked if we have too long, if our title is too long and we want to put to the next line, how do we do that? Okay, so we use another function called paste. Okay, like our famous copy paste. Okay, we will paste. Okay, how do we paste? We will paste whatever we want. Okay, mosaic. Okay, I'm going to try it again. Okay, you can history, and then you put comma. Okay, so everything can be pasted together between comma. And next one, and say and smoking history. This is how you combine your script, your text together, and then run this. Okay, so you will see that this will be only one line. So this is how you put to the next line if you have a long text. And if you go back to the documentation, I think there is another comment called color. Okay, so why don't we put it? Why don't we add color to our graph? So anyway, you can just quickly read this. Okay, color is a logical value. Okay, so you can put true or false. Okay, we will put true. We want color. Okay, so it must be true. Okay, so it's looking nice, right? So when you go back, everything is the same color, uniformly, not attractive. So we gave it a gradient color. So it's I think it is more apparent, more appealing to our eye. So as you can see that those who never smoke, okay, do not have family history because it is the bigger one. Okay, something like that. So this one is the biggest one. So anyway, this is how you do this in, this is how you do this, how to make Mosaicplot in R. So I think I'm going to remove this because we are assigning it. We don't want to assign anything. We just want to make plots, okay? We don't want to assign anything because we are just exploring data. We haven't reached to the final stage where we export our result and create it as a finite table, okay? I think giving the final touch to your analysis is also important, but we will do that at the end of our class because it is still early. Okay, so anyway, let's make sure that everything from top to bottom runs perfectly well. Okay, so we will run the whole R script by pressing Ctrl+Shift+Enter. Okay, so we should have only one data set and we are making plots on this one. Okay, so any questions? I think you can give, different color scheme, like green, different color value, like green, yellow, blue, something like that, not gradient color. But I think it's a little bit complicated to discuss that in our session. So right now, just leave to this gradient color. But remember, we can change this color as we want. Okay, any value we can change. So R is very flexible. Okay, if you don't have any questions, then let's move on to Scatterplot. Okay. Okay, so I think right now the only plot left is Scatterplots that's used when you have two numerical variables. When you have two number variable. Okay, how do we do scatterplot? Do we have a scatterplot function? No, we only have plot. Okay, no scatterplot. So you can search for a documentation by saying question mark and plot. Okay, so this is the plot function. So it is very generic. Okay, so you can read this on your time. Okay, anyway, whatever we do, right? Okay, so let's see. We want to see how age correlate with BMI. Okay, we have age variable, we have BMI variable. But first, let's put our data set to the pipe. And now, we just want to summarize age and BMI, okay, and see if any invalid value. So you remember we have this invalid value in age, right? So BMI seems to be okay. Minimum is 18, maximum 58. So seems to be okay. Okay, so we remove this and then we change the value. Okay, so this is how you explore your data and then do your data management. So you can do this very quickly. We replace age with any if age is more than 100. Okay. Or if you only have one value, you can just say that one value. Okay. But to be sure, we just put the maximum valid value 100 and then trying to see. Okay. Anyway, okay. We don't need to change BMI. So at this point, what we are going to do is we are going to give put this into plot function. Okay, so there is no data argument in plot. Okay, because in Mosaicplot there is a data argument. So we don't have any data argument in plot. So what we have to use is we have to use with function. Okay, with, so we put dot, and then we plot. It's fairly easy, age and BMI. That's it. Okay, so you remove invalid value from age, and then you plot, give a data set name with using the width function, the function width, and then you plot it using plot function, and then trying to see how it goes. Okay, so here's our scatter plot. Okay, and again we don't have any title, so let's add a title. Okay, we are going to put it to the next line, just to give it, you know, the first line we only want variable. Okay, Sashi.
No, I'm confused. In what condition do we use with function? Can you please repeat it again?
Okay. When your function do not have data argument, does not have data argument, you use with function. Okay. So here in Mosaicplot we have data argument. So you just specify data with the dot. Okay.
Okay.
The reason we are specifying it is the data argument is not the first argument. Okay, so let me just look at this tabulate function. So this tab function comes from Amsterdam. Okay, it has the data argument, which is the first argument. So if it is the first argument, you don't need to specify data set when you use piping function, because it is automatically put to the first argument. So that's why we can just, you know, write everything without specifying, without mentioning the data set. Okay. Otherwise, if we use it alone without piping function, we have to mention the data set name. So that is the difference. When you go to the Mosaicplot, you can see that the data argument is far behind, right? It's not that first argument. So you need to specifically mention that this data use dot. Okay, so when we remove this argument, what do you think it happens? Okay, let's run this. Okay, you see there is an error because the function doesn't know which data set to look. So that's why you need to specifically mention that we use the data set that is passed in the piping function, which is indicated by dot. Do you get it? So for plot function, we don't have data argument, so we use with. Okay, is it clear?
Yes, thank you.
Okay. Okay, so we will put the title of our scatterplot. Okay, say scatterplot between age and sex. Okay. Okay, sorry, age and BMI. Let's run this and see we have a title. Okay. Okay, right now we have age. Like somebody asked the other day, what if we want to change this label? Okay, so the label on age exit, so we call it age lab. Okay, age label in short. Okay, so we say that it is age in years, and we also change the label on wine exit. Then we say wine lab is equal to body mass index. You can even specify, okay, kg per meter square, something like that. Okay, so the reason I am writing in this way is for you can read it easily, right? If you just put everything behind this line, it's a little bit clunky. So you can make your code a bit cleaner so that we can read easily. Okay, let's run this. So as you can see that we have this one, okay, body mass index and then age. Okay, you can explore this documentation and see how we can change our plots pattern. Okay, so there are a lot of arguments, and then you can read details, or if you don't want to read it, then you can just Google it, how to add color in this plot. Because these are developed by different people, so sometimes they don't even have the same argument name, but they still work the same function, okay, the same thing. So let's say, let's check, let's try if our color argument works here. Okay, I want to look at red. Okay, it works, right? So we have a scatter plot, red scatter plot. So we have to look at green. Okay. Okay, gray. Okay, it's not good, right? And black is automatic, right? Okay, so this is, I think this is how you create different graphs for different variable type. So any questions so far? Okay, so I think starting from tomorrow, we will start discussing about inferential statistics. Okay, so I think you will be a little bit more happy if you hear about the p-value, t-test, which is very popular in papers, right? Articles, scientific articles. When you read it, they talk about, okay, p-value, t-test, we did that, we did this, something like that. So I think you will be excited because these are just what we have discussed so far are just descriptive. So we just explore our data. We didn't use our sample to try to estimate our population, right? So the process of estimating your population parameter based on your sample values is called inferential statistics. Okay, so it's a little bit, strange language, right? Okay, anyway, starting from tomorrow, we will talk about the theory behind inferential statistics. Okay, we won't just dive into t-test. Okay, we won't just dive into chi-square test. We will talk about why we can do t-test and safely say that these are statistically significant or not. Why we can look at the p-value and say, okay, this is what our population looks like. Okay, so there is a foundation theory behind these hypothesis testing. Okay, these are called hypothesis testing. You have a hypothesis, and you test your hypothesis whether. I think our one of our senior supervisor back at the school, he talked about this, like science is always rejecting your null hypothesis, right? Trying to because you don't know what is the reality. So you try to say that it is not, this must be true if that is not the case. So I think you will see starting from tomorrow that, that the language will change a little bit, okay? We will talk a bit more like scientists or researchers, and think our research questions in that way, okay? And we will formulate some hypotheses and trying to look at our data set and see if these hypotheses are can be rejected or fail to reject based on our samples. Okay, so if you have any questions, just let me know by posting your questions on our Facebook group. Otherwise, I think this is the end of the day. So no questions, right? Or you have any questions?
Not for now. Thank you very much.